Welcome to Cambridge IGCSE Physics, Lesson 7.1, Scalars and Vectors. This is core content for your examination. Today we explore fundamental concepts that distinguish between quantities with magnitude only and those requiring both magnitude and direction. These concepts form the foundation for understanding motion, forces, and many other physics topics. Let's begin our systematic study of these essential physics principles. Let's examine our learning objectives for today. By the end of this lesson, you will be able to first, understand that scalar quantities have magnitude only. This means scalars are described completely by a number and unit. Second, understand that vector quantities have magnitude and direction. Vectors require both size and directional information. Third, distinguish between scalars and vectors in physics contexts. This skill is essential for problem solving. These objectives align with Assessment Objective 1, which tests knowledge and understanding, and Assessment Objective 2, which tests application of concepts. Now let's define our key vocabulary. Each term is essential for understanding this lesson. First, scalar, which means a physical quantity described completely by magnitude only. Examples include mass, temperature, and distance. Second, vector, which means a physical quantity requiring both magnitude and direction for complete description. Examples include velocity, force, and displacement. Third, magnitude, which means the size or amount of a quantity, expressed as a positive number with appropriate units. Understanding these terms precisely is crucial. We use SI units, which stands for International System of Units, throughout our calculations. Let's explore our first core concept. Scalar quantities. The fundamental principle states that scalars have magnitude only. This means they are completely described by a number and appropriate unit. The definition is, a scalar quantity is completely described by its magnitude, which is its size, an appropriate SI unit. Key features include, no directional information is needed, scalars are added using ordinary arithmetic, and common examples include mass, time, temperature, and energy. The diagram shows typical scalar quantities with their values and units. Notice how each requires only magnitude and unit for complete description. Now we examine vector quantities. The fundamental principle states that vectors have both magnitude and direction. This means they require two pieces of information for complete description. The definition is, a vector quantity requires both magnitude and direction for complete description. Key features include, direction must always be specified. Vectors are added using special vector methods, not ordinary arithmetic. And examples include velocity, force, and displacement. The diagram shows vector quantities with arrows indicating direction. Notice how each vector has magnitude, shown by arrow length, and direction, shown by arrow orientation. The blue arrow represents velocity of 10 meters per second eastward. Now let's learn to distinguish scalars and vectors systematically. The decision method is simple. Ask, does direction matter for this quantity? If yes, it's a vector because direction affects the meaning. If no, it's a scalar because only size matters. Common pairs demonstrate this. Distance is scalar because 10 meters is complete information, but displacement is vector because 10 meters north is different from 10 meters south. Speed is scalar. 50 kilometers per hour describes motion completely. Velocity is vector. 50 kilometers per hour northward gives directional information. Mass is scalar, but weight is vector because it acts downward due to gravity. Let's work through our first example. The problem asks us to classify these quantities as scalar or vector. Mass, velocity, temperature, and force. We apply our decision method to each. First, mass. 5 kilograms is a complete description. We don't need to know the direction of mass, therefore mass is a scalar. Second, velocity. 20 meters per second eastward requires directional information. Velocity without direction is incomplete. Therefore, velocity is a vector. Third, temperature. 30 degrees Celsius is complete. Temperature has no direction. Therefore, temperature is a scalar. Fourth, force. 10 newtons downward needs direction because forces act in specific directions. Therefore, force is a vector. Example 2 demonstrates the difference between distance and displacement. The problem states a student walks 100 meters north, then 50 meters east. We analyze this systematically. First, total distance uses scalar addition. 100 meters plus 50 meters equals 150 meters. Distance is the total path length. Second, displacement requires vector addition because it's the straight line distance from start to finish. Third, we use Pythagoras' theorem. Displacement squared equals 100 squared plus 50 squared. Fourth, calculating. Displacement equals 112 meters at 27 degrees east of north. The diagram shows the path in blue and displacement in red. Now practice what you've learned with these 3 questions. Question 1 is basic level. It asks, which are vectors among speed, weight, time and acceleration? Apply the direction test to each quantity. Question 2 is intermediate. It states, a car travels 60 kilometers in 1 hour. Is this speed or velocity? Consider what information is given and what's missing. Question 3 is advanced. The question asks you to explain why temperature is scalar, but heat transfer can be directional. This tests your deeper understanding of the concepts. For all questions, remember the key principle. Does direction matter for complete description? Write your answers now before looking at the solutions. Physics principles power our modern world. Let's see how today's concepts apply in practice. In navigation, GPS systems use vector displacement to provide accurate positioning. The system calculates your exact location using vector mathematics, considering both distance and direction from satellites. In engineering, structural forces require vector analysis for safety. Engineers must consider force magnitude and direction to design safe buildings and bridges. In weather forecasting, wind velocity combines speed and direction data. Meteorologists report wind as vectors because direction significantly affects weather patterns. Career-wise, pilots navigate using vector principles. Engineers analyze vector forces. Meteorologists track vector wind patterns. And robotics engineers program vector movements. Let's review the solutions. For question 1, weight and acceleration are vectors because direction matters. Weight acts downward due to gravity. Acceleration has direction of motion change. Speed and time are scalars. For question 2, this describes speed only because no direction is given. Velocity requires both magnitude and direction. 60 kilometers per hour eastward would be velocity. For question 3, temperature is a property of matter with no directional component. Heat transfer is directional because thermal energy flows from hot objects to cold objects. Exam success tips. First, identify scalars and vectors by applying the direction test systematically. Second, use proper vector notation with arrows or bold text when required. Third, include appropriate SI units in all answers. Fourth, understand command words. State means give facts. Explain means provide reasoning. Let's summarize today's lesson. The key points to remember are: first, scalars have magnitude only. Examples include mass, time, distance, and speed. These quantities are completely described by a number and unit. Second, vectors have both magnitude and direction. Examples include force, velocity, and displacement. These require directional information for complete description. Third, use the test, does direction matter, to classify any physical quantity correctly. These concepts form the foundation for understanding motion and forces. For further study, review scalar and vector examples regularly. Practice classification exercises to build confidence. The next lesson covers distance and displacement, which builds on today's work by exploring these specific scalar and vector quantities in detail.